All right, this video kind of follows up on industry standard shared parameters. It's talking about standardized connectors. How are those shared parameters being at the connectors, and how do we standardize connector settings so that as manufacturers make families, we can use the families how we want to. We can get flow propagation and air side and fluid side, water side systems. We can do calculations. We can use we can look at connected flows compared to design flows and all of those scenarios. So how do we do that? We do that by standardizing how the connectors are set up. So I previously provided an Excel file for these settings, but now this is built right into the user manual, which is intended for manufacturers to refer to as they're making their families. So this right here is for you manufacturers and also for family content developers. You'll see why we've used the settings we've used throughout this user manual as we talk more about flow propagation and how we're flowing information in all the different systems. So this is at the end of chapter M2 in the user manual. These are the connector settings. These define air terminals and how we've set those up. Duct connectors. So we talked about the benefits of using inlet and outlet ducts parameter names, instead of supply and return. And then we also have vent duct connections and exhaust duct connections for like flues and power exhaust hoods and economizers and things like that. So then on the piping side, really flow propagation boils down to plants. Someone's making a resource and someone's using it. And that's how we've set up these pages. This is meant to be the consumer. So for chilled water, the chilled water plant, for example, these are the connector settings for the consumers, for all the coils of the chilled water. And then the chiller that's making the chilled water, here are those settings. So once again, these are set up for flow propagation, pressure drop calculations, all of that. So rejection water plant, you have consumers, the water source heat pumps, and then you have the creators of the condenser water, the cooling towers and fluid coolers. Heating water, same thing. We have the families using the resource and the families making the resource, the boilers. Gas connectors are summarized in here, condensate, also pumps. Pumps have some unique settings in Revit to get flow propagation to work, and these are actually the only connectors typically that I see linked. So DX connections, and then power. That's a very important one for all the mechanical equipment. How should that connector be set up, and what parameters are linked to those system parameters? And then plumbing fixtures. So they're all right here. This is meant to be a publicly available chapter for manufacturers and anybody making content. If you follow this as a guide, you will be able to propagate flow throughout your systems, and the users that acquire your families are going to want to use your families. You're going to have a better chance of getting into schedules because your stuff will function and will save them time doing their designs. So those are the settings. Let's look at a couple families and how this all came about. This is also in the user manual. So how do we make sure that every family has the right settings? Well, when we developed our content, we made one family. We set up every connector. This is what I'm calling the mechanical equipment configurator. We're going to be talking a lot more about this throughout the user manual, but essentially this was stop one. So we set up all these connectors that each are on their own articulated Cartesian arms for placement wherever they need to be, and this is meant as a reference for people. So if we look at what that family was created, and it was used to create all the other families. So like for the example of a VAV box. So now all the other parameters have been stripped away, the arms have been stripped away, and we're left with just some of the remaining duct connections that occur. So like the supplier duct connector on this VAV box, it's set to calculated. So it's going to look at the connected airflow from all the air terminals. The inlet is set to preset. So it's going to drive airflow into the air handling units and rooftop units. If we were looking at a hot water reheat box. So once again, I mean, we have supply and return connectors. So the whole intent is to keep this as consistent as possible across all the families and give users the ability to propagate flow. So we'll be talking more about the sample project and what systems we've been able to flow in the next video. Thanks.